So remember that propagating an exception means that an exception is thrown and Java looks in the current method to be able to handle it, but can't. And so it goes to the previous method that invoked where you currently are. That means it propagates the exception from where you are up to the previous method. So an exception can always be handled at a higher level like that. So there might be cases where you don't think it's appropriate to handle the exception right where it occurs, but you want to handle it in a different method somewhere up the calling hierarchy. That would mean you want to propagate the exception. Okay? You would do that by putting that, so in the method that invokes the method where the exception is going to happen, you would put that method invocation inside a try block. Because basically you're saying, okay, well, the second method that I'm going to call, an exception might happen there. So I'm going to put that method call inside a try block. Just like I would put, my parse int method inside a try block, I can put my invoking of my own method inside a try block, and then have catch statements to handle it. So this is really best seen through an example. So I've written a little program called exception scope, and it's just a kind of a simple program to show you how propagation works. So here we have three methods, level 1, 2, and 3. The level 1 method just prints out that we're in level 1, and then we have a try block, and in the try block is just one invocation of the level 2 method. Okay? And then we have a catch block, so we're saying that we might have an arithmetic exception. And if we do, we're going to print out the exception, print out the call stack trace inside the catch block. As an aside, you see here that here we are invoking get message and print stack trace on the object problem. That's why we give this exception object a name inside our catch block header, is because we can actually, this is an object and we can invoke methods on it like get message or print stack trace. Okay, so in my previous examples, I did not do that, but that's always an option, and that's why we give this object a name. Okay, so it is like a parameter, and it's an object, so we can invoke things on it. So then after our try catch block, we have the printout level 1 ending. So this is our level 1 method. Our level 2 method just prints out, hey, I'm in here starting level 2. It invokes the level 3 method, and then it ends, prints out an ending message. And level 3, here we're just going to use the exception of, again, dividing by 0, just because it's an easy one to generate quick. So we'll print out that we're starting level 3, we'll try to divide by 0, and then we'll print out that we're ending level 3. And then I just have a main method that creates an exception scope object, starts the program, and invokes level 1, and then ends the program. So let's actually run this program first with no exceptions. This is going to be our normal execution flow. So here we can say our program starts, level 1 begins, level 2 begins, level 3 begins, and then in level 3 we just do the division no problem, and level 3 ends. Control passes back to level 2, which ends. Control passes back to level 1, which ends. Control passes back to main, and the whole program ends. So please make sure that you first understand how this program works with no exceptions. Make sure you understand the normal execution flow, because if you have any uncertainty about that, then the exception flow will definitely not make sense. So make sure you understand the normal flow of execution and post any questions about that before continuing on as we look at what happens when an exception does occur. Okay, so let's make that exception occur, just dividing by 0, and let's run the code. So what we have here is program starts, level 1 starts, level 2 starts, level 3 starts, and that's where our exception happens, right? So here is where the exception happens, and what we get on our printout is the exception message, call stack trace, level 1 ends, and the program ends. So let's see how we got there. Okay, so we invoked level 2, we started level 1, invoked level 2. So this level 1 method is kind of put on hold. Level 1 is kind of in waiting now until level 2 stops. So we jump to level 2, we start executing level 2. We print out our starting message, and then we have another method invocation of level 3. So now level 2 is also put on pause. Okay, so we have level 1 paused as it waits for level 2. We have level 2 paused as it waits for level 3. And then we go to level 3, we declare some variables, print out our message, then we try to do our division, and this is where our exception is thrown. So here Java has thrown an exception. So what does it do? It looks to handle the exception where it happens. That's always what it does first. So it says, okay, can this method where that exception happened, can I handle it here? Is there a catch block that tells me what to do with this exception? And there is not. So that means I am done with this method. This method is over. I can't handle the error here. I need to go up a level to wherever I got here and try there. So this line here, the code that comes after the exception, will never be executed. And you can see that it's never in our printout level 3 ending. So when the exception happens, if it can't be handled in place, this method is just done. I never get to any code that comes after it. Okay? So level 3 is now done. We go to the previous method that was on pause, that was level 2, and we say, okay, here's where I was when this method was put on pause. Let me resume this method, and let me now look to see if I can handle the exception here. In this case, I can't, right? There's no catch statement to help me with this kind of exception in level 2, so I'm done. Level 2 can't be finished. So again, this line of code after where the exception happened will never be executed. You'll never see level 2 ending print out. But we say, okay, let me go up to the next method in the call stack to see if I can handle this kind of exception there. And so I go up one level to resume the level 1 method that was put on pause. That resumes here, and I say, oh, okay, this is where I left off. So can I handle it here? Oh, there is a catch block that matches my type of exception. That catch block is for arithmetic exceptions. That's the kind I have, so perfect. I can execute this catch block. You're telling me how to handle it. And what you're telling me to do is print line, print the message that is associated with the exception. That message is divide by 0. Print the call stack trace, so that's this. And then print another print line, and that's it. The catch block is done executing. And now I can just resume with my normal control, picking up at the first line after the try catch, which is printing out level 1 ending, which prints here. So again, even though I did eventually find a place to catch that exception, I never kind of go back to finish the methods that weren't done. They're just done. They're gone. Once an exception happens in a method and it can't be handled there, that method is done. We never come back to it. Never look back. Okay? But once I do catch it, if there is code there after the try catch block, then that will, continue on. And once we finish level 1, then we just continue back to main and print out the program ending message. Okay? So this is an example of propagating an exception. The exception is thrown in level 3. It's propagated to level 2, which propagates it to level 1, and then it's caught in level 1. Now, if we didn't have any of this exception handling stuff, let me just comment it out, we could still run our program, right? But what would happen is we would start it. We'd start level 1, level 2, level 3. That's where the exception is thrown. Again, it can't be handled in level 3. So we go to level 2. It can't be handled in level 2. So we go to level 1. Now, because I've commented that out, it can't be handled in level 1. So this line's never printed now. So we jump to main. It can't be handled in main, and so we just quit. So this line is also never printed. Okay, so this would be an example of an exception being thrown, propagated to level 2, and ignored. It does get propagated as Java tries to handle it, but it never finds a way to handle it, so the program just crashes. But with our exception handling code in there, again, it gets thrown in level 3, passed to level 2, so propagated to level 2, who passes it to level 1, who catches it. And then control continues. Okay. So let's now, so I said before, make sure you understand how the flow of control works without exceptions being thrown. Next, make sure you understand how the flow of control works if an exception is thrown and caught somewhere else. And now we're going to add one more level of complexity onto it. So now we're going to look at what happens if there's a finally block. Okay, so now in level 1 is the same. We have a try and a catch. In level 2, we've added a try and a finally. So let me say this now for a moment. Try statements have to have a partner. Typically, they'll have a catch, but they can also just have a finally. So you can have a try and a single catch. You can have a try and multiple catches, like we did in code entry. You can have a try, one or more catches, and a finally, or you can have just a try and a finally. You cannot have a try on its own. So a try block has to have a partner. That partner has to either be a catch, or it has to be a finally, or it can be both. But you can't have a try on its own. Okay, so level 2, we've added a finally. So we're going to try these two statements, and then we have a finally block. And then in level 3, we again added a finally. So here we have a try where we try to do the division. We have a finally block that just is our level 3 ending print line. And then we also have a line of code outside the try finally. So let's again run this with no exception being thrown. And it'll look pretty much the same as it did before. The program starts, level 1 starts, level 2 starts, level 3 starts, level 3 ends. That's in our finally. And then also this line of code outside of the finally gets printed because no exception ever happened. So we do the try, do the finally, then we do whatever else is in the method. And then we loop back around, level 2 ends, level 1 ends, and the program ends. Now let's see what happens if we do throw an exception. And here we have the program starts, level 1 starts, 2 starts, 3 starts, level 3 ends, level 2 ends. We have our catch clause code, level 1 ends, and the program ends. So let's see how we got that. So program started, invoked level 1. So up in level 1, we printed out level 1 beginning, tried level 2. So level 1 goes on pause. We jump to level 2. In level 2, we print out level 2 beginning. Level 2 puts put on pause as we invoke level 3. We get to level 3, and we create our variables, print out level 3 beginning, and then we try to execute this line, and exception is thrown. So Java first looks to handle this exception in the level 3 method. Is there a catch block that can handle an arithmetic exception? There is not. So that means we have to propagate up to the previous method to find code that can handle it. But before we do that, we execute the finally. So we execute any code that's in the finally, and then we leave the method. So we never get to this line here, but we do get to this line here. Okay, so before we propagate this exception, we execute the finally. And then we say, okay, now level 3 is done. Let me go back to where this was called from, which is here. Let me resume level 2. Can we handle the exception in level 2? Is there a catch block to handle it? No. No catch block to handle it, so let me look for it somewhere else. But before I leave, let me do that code in the finally, print out level 2 ending, and now I'm done with level 2. So then I go back up to level 1, resume that method. Is there a place here to handle the exception? Oh, there certainly is. So I do my catch code, I do my code after, and then control returns to main, and I do my code after that. Okay? So this code here shows you, it gives you examples of how to trace through code, of how the flow of control works when exception is thrown, when an exception is not thrown, when you have try catch finally, try finally, and it most importantly just shows you what happens with propagating exceptions when an exception happens in one method but then is handled somewhere else. Now, the reason why you might want to do this is, let's say you had several methods where a similar type of exception could occur. So let's say you had a level 1 method, and then you had level 2, 3, 4, 5, and 6 methods, and in all of those methods the same exception might be thrown, and all of those methods were invoked from level 1. So for example, you have level 1 method, and inside that method we invoke level 2, level 3, level 4, and level 5. And let's say in all of these methods the same exception might be thrown, then it might make sense to put the catch block or the exception handling statement inside level 1 so that you only have to write it once. And then if the exception happens in any one of these places, control can get passed back up to level 1 and handled there before your code moves on to do the rest of the code. of the invoking statements. Okay, so if you have lots of like kind of sub methods that might execute the same kind of exception, I'm sorry, throw the same kind of exception, then it might make sense to push that exception handling up a level in your call stack trace. Okay, so that's an example of why you might, or when you might want to use exception propagation.